Perception can be defined as a set of processes by which we recognize, organize, and make sense of stimuli in our environment. Perception is our brain's way of making sense of the world and providing reason to it. We don't necessarily need to see or hear to believe, and perception is entirely responsible for that. A classic example of perception would be the age-old question, if a tree falls in a forest but no one is around to hear it, does it make a sound? If you ask that question to a cognitive psychologist, the answer would probably be yes. However, some people argue that the answer could be no. The explanation is as such. We use contextual information and prior knowledge to deduce that an object as heavy as a tree will make a sound when it falls at full force to the ground, regardless of its location in relation to ourselves. We wouldn't hear a tree falling to the ground in Mongolia per se, but we could perceive that it does in fact make a sound based on this knowledge. For the purposes of this video, I will focus solely on visual perception. Understanding how visual perception works can be crucial to success in various professional settings, but first, it is important to have a basic understanding of how, biologically, we see. Light passes through the protective covering of the eye, known as the cornea. It then passes through the pupil and onto the crystalline lens and the vitreous humor, which is a gel-like substance that makes up a majority of the eye. The light then focuses on the retina, where electromagnetic light energy is converted into neural electrochemical impulses by photoreceptors. There are two types of photoreceptors, rods and cones, which are directly connected to the brain and are partially responsible for filling in the details of the objects that we see. Rods help us perceive darkness, and cones help us perceive color. The electrochemical impulses processed by the rods and cones then travel to the ganglion cells, which collectively form the optic nerve, one for each eye. The place at which the two optic nerves join is called the optic chiasma, which is responsible for routing the imagery to the thalamus in the brain. Once the image has reached the thalamus, neurons then carry the information to the primary visual cortex in the occipital lobe of the brain, where the final image is produced and processed. It's an extremely complicated procedure that happens all in a matter of nanoseconds, which is part of the reason why visual perception can prove to be fatally unreliable at times. However, if we can understand its principles and their application to our everyday lives, we can overcome its weaknesses. One of the more practical applications to demonstrate the importance of visual perception is with driving, and any driving instructors who might be listening should be sure to take note. There are four main concepts to understanding perception aside from the biological processes: distal objects, informational mediums, proximal stimulation, and the perceptual object. Now, these can sound a bit overwhelming at first, but I'll simplify them. Let's look at an example of driving a car while keeping in mind these four concepts. The distal object, as it relates to this scenario, could be anything from a deer, another car, a biker, a pedestrian, you name it. Simply a physical object within our view. The movement of these objects, whether they are moving further or closer to us, creates a pattern on an informational medium or the method in which we receive the information. In this case, it would be reflected light through the process mentioned earlier. When our brains absorb those waves of reflected light through the appropriate sensory receptors, this is called proximal stimulation. Once this occurs, we then form our perceptual object, or the image that reflects the properties of the external world. In the case of driving, this would be an image of an oncoming car created on our retina that reflects the oncoming car that is actually in front of us. In order to better understand visual perception, psychologists sought to distinguish two different views on how we perceive the world: bottom-up theories and top-down theories. Top-down theories suggest that visual perception first comes from the brain and takes a constructive approach. We construct a cognitive understanding of a stimulus, then our concepts and cognitive processes influence what we see. Bottom-up theories suggest that our environment supplies us with all the information that we need for perception. If we looked at driving from a bottom-up approach, we could apply a few different sub-theories to help us understand how we perceive the information around us, namely the theory of direct perception and the recognition by components theory, or RBC theory. According to the direct perception theory, the only information we need to perceive anything is what is provided to us by our senses in the physical world. Our environment supplies us all the information that we need for perception. You know that a person is moving further away because of how few details you can see. You know that a car is moving faster based on how quickly its visibility is either growing or deteriorating. It is easier to make split-second decisions like we must while we are driving when we rely on the image of our environment rather than relying on retrieving prior knowledge from our brains to make sense of a situation. The direct perception theory helps us understand that sometimes we think too much, which, in the case of driving, can prove to be fatal. We must be vigilant while we are operating 2-ton motor vehicles, and again, relying more on advanced cognitive processes to perceive the world around us can be dangerous. We can also rely on the RBC theory to help us better understand our environment. RBC theory focuses on our brain's ability to recognize objects by examining their edges and then decomposing them into small, simple geometric shapes called geons. According to this same theory, we can then recompose those same geons into alternative arrangements. In terms of driving, we can see the outline of a moving object and know that it must be a car or some other type of vehicle. We can recognize a stop sign even if it is obscured by other objects. We know a car is still a car even if it is dirty or there are parts missing. Again, there are no higher level cognitive processes going on, just our environment supplying us with the information. But to become better drivers, it is extremely important to understand that increasing our ability to perceive information while driving will require a complementary approach to both top-down and bottom-up theories. We will need to apply elements from both in order to be the best that we can. Yes, we definitely require environmental and contextual information to perceive the world, but we also require advanced cognitive processing to perceive situations more analytically and thus acting in a more effective way.